Example 4 for Cramer's rule. We want to set up our determinants here, so we want to find our x-coordinate for where these two lines intersect. There's our top determinant, our bottom determinant. For the denominator, you want to have both the x column, the y column. In the top, you want it, because you're solving for x, you want to have c and then y. And so I can call this 5, 2, 3, negative 1. 5, 2, 3, negative 1. For the bottom, I can go 2, 5. And the y's, I'll go 3, negative 1. I'll be careful here. I notice as I'm doing this problem here, it might be a little confusing. The c's were over here, it's 5, 2. And the x's were here, 2, 5. Using the same numbers, but they're in the reverse order. Watch that and be careful. As I multiply this out, I go 5 times negative 1, which is negative 5, minus, you always put minus as part of that formula, 2 times 3 is 6, over 2 times negative 1 is negative 2, minus automatically, 5 times 3 is 15. Now the beauty of Cramer's rule, the first couple examples I made them so that they came out nice. This one I just threw the problems together. Look at what happens here. You owe me 5, you owe me 6, you owe me 11. Over, you owe me 2, you owe me 15, that's negative 17. That means that the x-coordinate for the point of intersection is 11/17. I don't think I would really want to do that with any of those other methods. That's a nasty answer there. And in a similar way, I don't really want to plug this back in for the x and try to find the y. I'm going to use the Cramer's rule method to come up with a y value. As I've said repeatedly now, when you do the y value, you can recycle this denominator. We know that's going to be negative 17. I don't have to reinvent the wheel. I already know what the answer for the denominator is going to be. I just have to watch that when I set it up, I'm trying to solve for the y, that I have the x column and I replace the y column with my constants. And so I'll go xc. I simply plug those numbers in there. The x column is 2, 5. The c column is 5, 2. Now I go 2 times 2 is 4, minus 2 times 2 is 4, minus 5 times 5 is 25. 4 take away 25 is negative 21 over negative 17, which would be positive 1 and 4/17. And so I can come up here. My solution is going to be x first, 11/17, and then 1 and 4/17. That's really the power of Cramer's rule. It allows you to get these nasty answers with relatively little work. You don't have to deal with a bunch of fractions. They come out, final answer is a fraction, but I didn't have to deal with it like in any of the math work. And so Cramer's rule is very useful for finding these non-typical points, these nasty solutions. There's your 4 examples for Cramer's rule.